Okay. So 42. It says x squared minus ax minus 20a squared. So that's descending order, leading term positive, and it's ascending in A. No common factor, trinomial, not a special case. So it's going to factor by trial and error, right? So we have an x and an x. What are the signs going to be? This right here says opposite signs. And then we have to have an a to get an a squared in that third term. So what, this is actually an a or a 1 right here. So is it going to be a difference or a sum of the factors of 20? It's a difference, right? Because the signs are opposite. So what two numbers times itself is 20, whose difference is 1. 5 and 4. So which one's got to be negative? The 5's negative and the 4 is positive. Then we take each one of those factors and set it equal to 0. And x is equal to a minus 4a, or x is equal to 5a. So let's look at 46. 3x squared minus 11xy plus 6y squared. So how do we analyze it? Zero's by itself, it's descending order in x, ascending in y. Leading term is positive. Is the special case? No special case, right? So it's going to be trial and error. It's going to be an x and an x. Signs are going to be what?
The same, both negative.
Okay, same sign. This says same sign, this says negative sign. And then we have to have a y and a y. So that 11, is it a sum or a difference? It's a sum. So we do our integer factors here. What's the combination that sums to 11? Okay, it's these two and these two. And you're going to put what? This 3 with what? That 3 to be 9. The one with the 2, 9 and 2 is 11. So does it make any difference where I put the 2 and the 3?
No.
No, I can put the 2 and 3 wherever I want. But now what has to happen? That 3 has got to be associated with what? That 3. So where does that 3 right there go?
Right. With the two on.
It goes to the on the left-hand side over here, doesn't it? So now we got it factored, and we set each factor equal to 0. And then we solve. 2/3 y. So our answers are these two things, right? B52 says 12x squared minus 5xy minus 2y squared. So zeros by itself, descending order in x, ascending in y, leading terms positive, not a special case, so it's trial and error. Has to have an x and an x. What signs?
Opposite.
Okay, plus and minus, and then it has to have a y and a y. So that 5 right here, is that a sum or a difference? It's a difference, isn't it? Because the signs are opposite. So what combination is going to give us a difference of 5? Okay, this 3 and 4, and you're going to go with a 2 with the 4, right? So now, we have to decide this 1 and 2. Where does the 1 and 2 go? Well, the larger product has got to be what? Positive or negative? It's got to be negative in order to get that. So which one, 1 or 2, is involved in the larger product? Okay, the 2 is involved in the larger product, so it's got to be negative. The 1's got to be positive. Now then, the 3 and 4, where is the 3 and 4 at? What goes right here?
4.
The 4 goes there because it's associated with the 2 to make 8, and that means the 3 has to go right here. So now we got a factor. This is 4x plus, and we'll just call it y, equals 0, or 3x minus 2y equals 0. So now this goes into x is equal to a minus y over 4, right? Or x is equal to 2y over 3. So either one of those is the answer. Okay. Now, the next thing says write a quadratic equation. Now that statement indicates that there's probably more than one quadratic equation that would satisfy it, that has integer coefficient and has as solutions the given pair of numbers. So 54. So what I'm going to do is I'm going to show you something. If you had x squared minus 4x plus 3, how would you factor that? You'd say descending order, leading term positive, no common factors. Not a special case, it's trial and error. So it would factor into what? X and X. Signs would be same sign, negative sign. Now, the 4 is going to be a sum, so two numbers times itself is 3, whose sum is 4.
3 and 1.
3 and 1. Now what would you do? Set each factor equal to 0. Solve each factor. And you would say the solutions are 3 and 1, right? Now, this says if the solutions are 3 and 1, find the quadratic equation that comes from. Well, obviously it comes from here, but how are you going to find it when you're given that 3 and 1? Well, this is what you're going to do. If this was the first step and the second and the third and the fourth and the fifth step, then what we have here is the fifth step, right? Now, what is the fourth step? You take those two, 3 and 1, and set each one x equal to each. That's the first step in your solution, is the fourth step in the other method. Then the next step is the third step, and that is you take x minus 3 equals 0, or x minus 1 equals 0. And then you do the second step, x minus 3 times x minus 1 . And then you FOIL that for the first step, x squared minus x minus 3x plus 3. Simplify it, and you say this is a quadratic equation for which the solutions are 1 and 3. There's your answer. You just do this one backwards. See that? How many see it? Let's see. Okay, then let's do 56. 1 and minus 1 and minus 3. What's the first step? What was the first step? Right there. So what are you going to do? X equals minus 1 or x equals minus 3. Then what's the next one?
7 equals 0.
Okay, x plus 1 equals 0 or x plus 3 equals 0. Then what's the next step? Multiply each of these together, right? Then perform the FOIL, x squared plus 3x plus x equals 3. Oh man. Plus 3 equals 0, and then combine. And there is a quadratic that has minus 1 and minus 3 solutions. Let's try another one, see what you can do. Minus 2 and 5. So what's the first step? Okay, x equals minus 2 or x equals 5. Then the next one is what? It's 0 by itself, x plus 2 equals 0, or x minus 5 equals 0. Then we do what? Take those two and put them in a binomial pair product. Then we FOIL it. combine like terms. And we see there is a quadratic equation that has as solutions minus 2 and 5. What about 60? 5 and minus 5. Well, you can do it the same way. X equals 5 or x equals minus 5. But you can also say this is x is equal to plus or minus 5. Right? You can say x minus 5 equals 0 or x plus 5 equals 0. X minus 5 times x plus 5. When you FOIL that, the middle term goes out and it's x squared minus 25, isn't it? So when you have this thing here, you can just go x squared equals 25, and that's x squared minus 25 equals 0. You can just square both sides like that. So anytime, if you had 3 and minus 3, what would you have? X squared minus 9 equals 0, right? Anytime you have that kind of a thing, that's what you have. Now, what happens when you have 62? 2 and 2. Previously we was doing 2 and minus 2, that would be x squared minus 4. What?
Positive x plus 4.
Okay. This thing, when you do this, is going to be x minus 2, x minus 2. So it's going to be this x minus 2, the quantity squared, which is x squared minus 4x plus 4. Right? If it were minus 2 and minus 2, then what would it be? X squared plus 4x plus 4. So you just, when you have plus or minus any number, it's going to be a difference of squares. When you have the two numbers a and a, if they're both positive, it's going to be x squared plus 2ax, no, minus 2ax plus a squared. And so on. So that, you want to keep that kind of a thing in mind when you're doing those problems. Now let's look at another kind of a problem. Let's look at 68. 2 and 2/3. Now what will we do with that? X equal 2, right? Or x equal 2/3. Then what are we going to do? What? Okay. One way we can do it is x minus 2 equals 0, or x minus 2/3 equals 0. Right? Then we can go x minus 2 times x minus 2/3 equals 0, and then FOIL that. X squared minus 2/3 x minus 2x plus 4/3 equals 0. Now then, to combine that middle term, what do we have to do? We have to do a 3 over 3, don't we? So we have x squared, and then we have a minus, this is going to be a 6, that's going to be a 2. So that's 8/3 x plus 4/3. Now there's another way of doing that problem. If you go from this point right here, if you take that 3 and multiply it by both sides, get 3x equals 2, and then subtract the 2. Now you got this term and that term that you can multiply together. X minus 2 times 3x minus 2. And you can FOIL that. 3x squared minus 2x minus 6x plus 4. 3x squared minus 8x plus 4. Now this is a quadratic that has those two things as factors. This right here is a quadratic that has those two things as a factor. Notice that if you multiply this particular problem, this right here, by 3, what do you get? You get that one. They're both a quadratic that has 2 2/3 as factors. Now which way you want to do it is up to you. But I would think this would be easier, going this way, getting that quadratic. And if you recall, that this is more typical of the kind of problem that got this as an answer than this one right here. Because usually what we would turn this problem here, get rid of the fractions in order to factor it. It'd be very hard to factor otherwise. So let's do another one. 78. We have 3/4 and minus 3 over 2. Okay, what do you want to do with it? Well, no matter how you do it, the first step is doing this. Now, you want to deal with fractions, or do you want to deal with it like the second way I did it?
Fractions.
What?
Fractions.
You want to do fractions. I don't want to do fractions. You can do it fractions.
Alright.
Why would you want to do it fractions?
I don't know. It just makes more sense to me.
It does. Okay. Well, you're going to see when you do common denominator, you're going to have to do that denominator inside there.
Yeah.
So I'm going to do it this way and multiply 2 and 2. Here I thought I would have everybody convinced to do it this way. X equals minus 3. So this says 4x minus 3 equals 0, or 2x plus 3 equals 0. 4x minus 3 times 2x plus 3. And then FOIL it. So we'd have 8x squared plus 12x minus 6x minus 9. 8x squared plus 6x minus 9. That would be a quadratic. Okay, do you want me to do any more of them? Okay, the next one, 84. No, it says solve by taking square roots. X squared equals 64. The way we've done this before is we got 0 by itself. And then we said that is a special case binomial. That's a difference of squares. And we said x minus 8, x plus 8 equals 0. And then we said x is equal to 8, or x is equal to a minus 8. Now what they want us to do, which will lead us to a method of completing the square to solve equations, is take the principal square root on this side and do plus or minus the square root on that side. So when you take the square root of x squared, is what number times itself is x squared? That's x. Equals plus or minus, and then what number times itself is 64 is 8. So this then is your answer. And that's just the square root method. Now when 88, when the problem is given to you this way, you can still do that square root method. This problem, you could do it as r plus 6, r minus 6. And do it that method to get r equals plus or minus 6. Or you can go r squared equals 36 and take the square root here, principal square root. That's the square root without a plus and minus, and this is just a regular square root. And then have r equals plus or minus 6. So this is the square root method of solving problems. Now, 90 is 9x squared minus 16 equals 0. So you can do the same thing with this thing. 9x squared equals 16. Now, because both of those things are squared, you can just do the principal on the left and the square root on the right. And the square root of 9x squared is 3x, right? Plus or minus, and the square root of 16 is 4. And then divide by 3. And that's just the square root method of solving the problem. Now problems that are like this, problem 92, where you have z squared plus 16. Now in the conventional method that we did, that's descending order, leading term positive, no common factor. It's a binomial special case. It's a sum of squares, and we always said that was non-factorable. We said that was non-factorable. Now, if you include a new number system and you write this thing this way, The new number system, if you consider the complex numbers, and you do square root, you go to square root of this side, plus or minus the square root of minus 16. Square root of z squared is z. Now, what I'm going to do is I'm going to write that minus 16 as a minus 1 times 16, right? So then on the right-hand side, that's plus or minus, and the square root of a product is the product of square roots. Correct? Now then, we can go plus or minus, and the square root of 16, the positive square root of that is 4. But the square root of a minus 1, what number times itself is equal to minus 1? There's no real number. So what you have, and what they do is they introduce a new number called I, which I squared is a minus 1. That's a new number system. That's imaginary numbers. And it leads to the complex numbers. Now this is the way our number system goes. We have counting numbers. That's 1, 2, 3. We have whole numbers. 0, 1, 2, 3. This goes on. These are all subsets of each. This counting is a subset of the wholes. Then we had the integers. And the reason that these were introduced is, I've talked to you about it before, is operations of addition and subtraction, multiplication, division, and taking square roots. They wanted to get number systems that would do that. Well, the counting numbers, you can add any two counting numbers and get a counting numbers. You can multiply any two numbers and get a counting number, but you cannot divide two counting numbers and get a counting number. If you take 1 divided by 2, it's 1/2, and that's not a counting number. So you can't divide in the counting numbers. You can't subtract in the counting numbers, because if you had 2 minus 3, that's a -1, and that's not a counting number. It's not a Roman numeral. So the operations of addition, subtraction, multiplication, and division. Now you can add, subtract, multiply, and divide in the integers, because you can add, subtract in the integers because they have the negative numbers with it, but you can't divide. You multiply, add, subtract. So then they brought in the rational numbers. And now then you can add, subtract, multiply, divide in that number system, because that's an integer divided by an integer. But then the numbers e and pi and the square root of 2 are not in the rationals. So then they introduce the irrational numbers. And they take those two numbers and we get together with the real numbers. That's the number system we've been dealing with. Add, subtract, multiply, divide, take square roots, except you cannot take the square root of a negative number. So what they do is they add the imaginary numbers, so you can take the square root of any negative number, because you can always factor out -1. And they put these two number systems together and get the complex. Complex numbers includes all counting, all wholes, all integers, all rationals, all irrationals, all reals, and they include the imaginaries. Now, why is the imaginaries important? Because you would not have a cell phone that worked if you did not have complex numbers. Because in order to figure it out, they have to have complex numbers. You could not go send a missile to the moon or rocket to the moon, because re-entry requires complex numbers. You could send it up, but you could never figure out how to re-enter the atmosphere. So who wants to volunteer to go up for the next mission and just go and never come back? Not many people would be willing to do that. Few might, but not many. So there's all of this technology that needs complex numbers. And the complex numbers is this imaginary thing that requires I. And so what you have is you have that, the answer to this problem is plus or minus 4I. So that's kind of, so now what we can do is we can figure out the answer to problems of sums of squares. Okay, 92. Now, another kind of problem that we can work out that we couldn't work out before is 94. S squared minus 32. Now that's a binomial, but it's not a binomial difference of squares. Now you'd be stuck with that problem if you couldn't do this. S squared equals 32, and then do the principal square root on this side and do plus or minus the square root on this side. So that this becomes S, and then what you do with that 32 is you prime factor it. 32's prime factors are what? 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, 2 times 16 is 32, so it's 2 to the 5th power, is that right? 2 to the 5th power. Now, what you can do is you can write this as plus or minus the square root of 2 to the 4th power times 2, which is square root of 2 to the 4th, square root of 2, and 2 to the 4th is actually 2 squared outside, isn't it? What number times itself is 2 to the 4th? 2 squared. 2 squared squared is 2 to the 4th. So this is plus or minus 4 square root of 2. So without this method, we wouldn't be able to figure that out. We wouldn't be able to figure out what that number was. Now, you might say, well, I can put 32 in the calculator and take the square root of it. But you know what you got? You got a rounded number. Because what is the square root of 2? Irrational number. And what is an irrational number? A non-repeating, non-terminating decimal. It's rounded off. This is accurate. That number is accurate. 4 times the square root of 2. It will be accurate in your calculator as far as your calculator has the ability to run decimal places on it. But if you take the square root of 2 and you round it off to 2 decimal places or 4 decimal places or 6 decimal places, what is that? A rounded number. It's not accurate. So it's important to be able to do that. Why was it important to do it? Because if you're taking the square root of 2 and it's involved in a problem for circumnavigating the moon, do you want to have somebody rounding off a number when you're setting up in that capsule going toward the moon to figure out how you're going to be trajected out there? You want to be pinpoint accurate. And you're not going to be pinpoint accurate if you round that number off. Because, you know, 1,000th of a degree off, when you go that far, is miles and miles off. Now, you might hit the moon, you might go out and never go around, just go skipping right off the moon and go out into space. Because how do you navigate in the universe? Gravity of planets. You go close to them and swing around it. How close you come, Depends on how much you swing. You got a little bit of jets to be able to kind of move you around, but not much. You swing out to the moon, you go to an orbit, and you orbit that moon, and then you use your little bitty jets to kind of make you go out and swing you back down to Earth. And you better swing out at the right direction, had you not. You better leave orbit at precisely the right thing to head to Earth. If you're not precise, what are you going to do? You'll go off someplace else beside the Earth. I mean, precision when you're going long distance is so critical, and that's why you want to be able to do this stuff. So let's do 96. Q squared minus 54 equals 0. So is 54 a squared number? You can't use your square principle, so we're going to go u squared equals 54. We'll do the principal square root of this plus or minus the square root of this. This is u equals plus or minus. Now, what you can do is you can say, well, 54 is 9 times 6, right? Rather than going 3 squared is 9 and 6 is 3 times 2, and then have 3 cubed times 2 is what 54 is, and have that underneath the square root, you can kind of cheat and do this, right? So then you have 3 square root of 6. And that's your answer. You'd get the same thing here, right? Because you would break this out as a 3 squared and then take it 3 times 2 left. And then when you did the square root of this one, it's 3. But this is kind of cheating. Because what I did is I took the square root of 9, square root of 6. So I'm going to finish up on Friday the rest of this section, and I'll start into section 10 too. And